First step is stiffness factor. Second step, distribution factors. Third step, fixed end moments. Fourth step, distribute the moments. The fifth step is to carry over the moments. If we have a beam span with both ends fixed, then the stiffness factor for that span is as follows. If the beam span has one end pin or roller, then the stiffness factors for the span is as follows. The second step determines the distribution factors for different beam span and conditions. Node A is fixed, so it will not distribute any moment. Therefore, distribution factor from A to B is 0. Node D is an overhang, and it will not take or distribute any moment. Therefore, distribution factor from C to D is 0. Node C will distribute all its moment back to node B. Therefore, distribution factor from C to B is 1. Node B is pinned, but it's not at the end. It will distribute the moment to nodes A and C. Portion that would be distributed to nodes A and C depend on the stiffness factor of each span, and it will be distributed proportionally as follows. Next step is to determine the fixed end moments. This depends on the type of loading over each span, its end supports, and its length. The fourth step is to distribute the moment at each node to the adjacent spans. The fifth step is to carry over the distributed moments to the opposite end from where they are coming using the following rules. I always like to use a table like this to keep track of my work.